Hi peeps, and welcome to another JavaScript basic video. I'm Zen, and in this video we are going to be looking at weak and strongly typed variables as well as the sequence operators. So without further ado, let's get into it. Okay, so as you can see, we've got our standard setup for playing about with JavaScript here. We've got our test1.js, which is part of this HTML file, okay? And it's this HTML file that we are viewing on live server with the developer tools in Chrome open and the console, so we can see the console logs, okay? If you're not quite sure on the setup, please see the earlier videos. I think it's JavaScript Basics 1, where we actually set this up for us to work in. Now, as you can see, we've got quite a few printouts here, and just to make it easier for us to see what we're doing, we're going to comment out all of the code. So to do that, make sure we're inside the code area. We're going to press Control and A to select it all, and then Control and / to turn them into comments. And then once we save that, which is again Control and S, we can see the update, it's all gone, and all the text is in green. To undo that, all we need to do is to re-highlight it using Control A, or to click and drag over the areas that we want, and then press Control and / just to uncomment it. Okay, with that out of the way, let's get into the actual work that we need to do. First of all, what are sequence operators? Well, sequence operators are essentially a comparison, okay? The sequence operator is the actual bit that says how are we comparing two values. It will always output one or two values, true or false, okay? In other words, it outputs a Boolean. Now, we'll normally see them in something like this, where we have an if statement, and if val1 equals val2, if this evaluation here is true, then it does the code inside these braces. If it's not true, it will ignore it and just go on to the rest of the code. We haven't done if statements yet. That's coming up in the next video. So if you hold your horses to find out more about that, we're just going to do this using console log again, because it's, well, it's what we do. So let's start off with actually creating our variable. So let val1 equal 8, and then let val2 also equal 8. And so what we're going to do is console log this out. So we're going to do console.log. Oops. And then we're just going to do val1 equals val2. Now, before we go any further, why do we have two equal signs, okay? Why are we using two to say, is this equal to this? And the reason for that is that in the more recent versions of JavaScript, okay, in the earlier ones, this wasn't the case, but in the more recent versions of JavaScript, a single equal sign implies an assignment operator. So we're saying, let val1 equal 8. In other words, we're assigning this value 8 into val1. We're declaring it. We are saying this is a fact. Val1 now equals the value 8. But we don't want to assign it here. We want to check if it's true. So we're saying that this two equal signs is saying, is val1 the same as val2? Okay, so we're doing a check. We're not doing an assignment, we're doing a check. And we can see that val1 is 8 and val2 is 8. So therefore, this is a true statement. So when we save it, we get true. Now, if we change the value to say 9, that statement is no longer true. And when we save it, we'll see that's the case. However, just pull it back to true. However, this is where the strong and weakly typed variables come into it. Now, I need to make this clear. This is a language-wide system, okay? So when I talk about weakly and strongly typed variables, it means the language is either weakly or strongly typed, not necessarily your code, okay, the actual language itself. And JavaScript is known as a weakly typed language. And the reason for that is this. If I change val2 into a string, okay, so now it's no longer a number, okay, it is a string which holds the character 8, but remember, as a string, the character 8 has no mathematical value. It is not the same as the number 8. Yet, when I save this, we still get true. Why is this? And this is where coercion comes in. And I love the word coercion. It makes me sound like I'm a spy or I've done something naughty. You know, what did you do this week, Zen? Oh, convert a string into a number. Kinky. All right. But, okay, maybe I need to go out more, but that's life. But that's basically what it is. Coercion, in this case, means that I've been able to take a string and I've coerced that value. I've converted it implicitly, and this is a key term. It's an implicit change, okay? So the system looked at it and went, is val1 the same as val2? Well, they're not actually the same data type, but can I convert this back into the same data type so that I can do a proper comparison? So in a way, the programming language is trying to help us, okay? And so it coerced, and I'm assuming it's value 2, could have done it to 1, but we don't know. I'm assuming it's coerced value 2 and converted it into a number type, okay? And now, this is the important thing to understand. The number one, the change was implicit, okay? There was nothing in here that said change val2 into a number, because there are functions for us to do that, and that would be an explicit conversion, okay? But this conversion was implicit, okay? It was done behind the scenes without being told to, and that's where we call it coercion. And also an important thing is that it has to be from a different family data type. And what I mean by that is that 8 is an integer, which is part of the number family. Converting 8 to a fixed point, like 8.1 or 7.8, okay, that's part of the same family. So that's not a coercion, that's not a change. As well as changing it to, 7.4 times 10 to the minus 3. That's a floating point, still part of the number family. Just like converting this is actually technically a character, a single string character. If we added more characters to it, that would change it from a character type to a string type, if, of course, that's supported by JavaScript. And that would still be part of the same family type because it is a string. So the coercion, the change must happen between different data family types. So we're talking about difference between a number type to a string or to a Boolean, or even perhaps to an object, okay? Those are, if you like, the primitives, and that's what we're talking about. The coercion is a change between those families. And this is, like I say, this is called a standard equality. Now, you may say, so, well, is there a way to check if it is exactly the same? So not just it's a string 8 and the number 8, but, are they both number 8s? And the answer to that is yes. We can use the 3 equals to represent strict equality, and that will tell us if they are exactly the same. Are they both numbers or both strings, and do they hold the same value? And then when I control and S this, we can see it comes out as false because they are not the same. But if I turn it back to the number 8 and then save it, we get true. Okay, now here's the thing. What happens if I make it 8.0? Notice it knows it's true. They're both a type number and both have the value of 8. What about 8.0 times e to the power of, let's do that, of minus 1, because that is actually a different value then. So that should be false. Yeah, because that is really 0.8. Let's change this to 0.8. And you can see it's basically converting them and check the numbers. Are the numbers the same? Okay, and that is strict equality. Okay, it's very important to understand the difference between strict equality, the 3 equals, and the standard equality, where it doesn't check for the actual data type, just for the values, or rather it coerces the data types to be the same. Okay, and that is the difference between them. So let's just bring these back to how they were. Okay, so that's the important thing to understand. Okay, a coercion is changing it from data types, and a standard equality will go for coercion and comparison, whereas with strict equality, it will not allow coercion, and it checks for the values as well. So same data type and same value. Okay, so that's the equals. Then the other ones are, of course, we have not equals to. Okay, and it's simply that, and that is, you know, are they not the same? So this will come out false because 8 is 8, they are the same. Okay, and now if we change it to 9, guess what? It comes out as true because they aren't the same. And again, we also have strict inequality as well. Well, what does that mean in this sense? Well, let's have a look. That is false, okay, because they are the same. If we do it like this, we get true, because now they are no longer the same. They're strictly not the same. So this doesn't allow that coercion. Remember, now we're comparing a string to a number, and we're saying, well, they're not the same. And that is what this statement is. You know, is this not the same as this? It's true. They're not the same. That's why we get true. Okay, so it's strict inequality and standard inequality. Okay, and notice again the difference between 2 digits and 3 digits. Okay, so the only ones after this are actually the fairly easy ones, which are greater than, and I'm sure you can work this one out yourself, but we will do it anyway. So again, this will be false because 8 is not greater than 8, and we get false. And of course, if we change value 1 to 9 and then save it, it becomes true. If we make value 280, it will once again be false. Let's change them both back to 8. And the sister of the greater than is, of course, the less than, which looks like that. And again, at the moment, it'll come out false because 8 is not less than 8. But we change value 1 now to 7. It will be. Okay, now if we change it to 70, it will be false. And what happens if we make it the string 70? So question, for that to work, we have to make it the string 7. And we get it true. So here we've done a coercion again, because 7 as a string, all right, well, it's a good one. Is 7 less than a string? You can't actually do that comparison because you're comparing a string and a number, and that just doesn't work. But it coerced the 7 into a number and then done the test. And it came out true because 7 is indeed less than 8. There is 2 others that we should really look at, and I'm just going to include them for completeness, but I actually strongly advise that you don't use them. And that is the less than and equals to. Okay, so this basically says, is value 1 less than or equals to val 2? And so at the moment, this answer should be true, which is what we get. And again, as we turn it to 8, that statement will still be true. And then when we turn it to 9, it will become false because 9 is not less than or equals to. Now, it's also got, of course, its sister version, which is greater than or equals to. The thing to remember here is that the less than or greater than sign must be before the equal sign, okay? You can't put it around the other way. And again, this one will come out true simply because 9 is bigger. Right, so why don't we recommend you use these? It's simple. You're causing the program to do 2 evaluations when it doesn't really need to. Okay, because what you're doing, evaluations like these do take up quite a bit of compute cycles. Okay, and so this is an inefficient method. All right, if we wanted, and quite often you have, like, say, the value 10. All right, so let's forget about val2 for the moment. So if you wanted to check if something is greater than or equals to 10, okay, well, why not just ask, if you're only dealing with whole numbers, why not just check that it's greater than 9? You get the same output, okay, you get the same true or false, but now the program's only doing one evaluation. Okay, so it's more computationally safe. If you're saying, oh yeah, but I'm dealing with fractions, well, okay, just do 9, 999, something like that. That's still only one test. Okay, whereas doing greater than or equals to 10 is forcing 2 tests, which is more compute cycles and is classed as inefficient. So where possible, do that. There will be times, absolutely, where you can only do greater or equals to, just due to the way the program has been written or the way the values are being produced. And you can't stop that. That's just the way it is. That's fine. Go with it. No problem. But where possible, try not to. But that's the end of this video. Thank you for listening. As always, please comment, ask questions below. I'll answer them as much as I can, as quick as I can. You know what all those other buttons do. I'll be seeing you guys in the next video. This is Zen, signing out.